As we finish this presentation, we're going to have a lot of summary slides, just kind of bringing everything together, and this is one of them. Remember, the main theme of this chapter is protection, 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 and we can protect against many different things. I just mentioned microorganisms climbing in your ear, right? We can protect it by cerumen, different chemicals, and throughout all of the epidermis, we have those keratinocytes that protect stuff from getting in, also even just water, protecting us from water seeping into our body. Same thing with mechanical injury. To prevent us from getting cut, and scraped, and bruised, we have those keratinocytes to make our skin nice and tough. We talked about the melanocytes, making melanin to protect us from the harmful UV light. Right? All UV light is not bad. You want UV light. It actually helps regulate your sleep cycle. So if you're an insomniac, you should go out and get some sun. That is a good thing. Just don't overdo it is all. And then also dehydration. We talked about how the sebum, the oil, helps with water loss. Also the keratin helps waterproof your skin as well. Going along the theme of protection, we have something called a surface film, which is basically just a thin film of materials that keep us clean from bacteria and fungus and parasites and those kind of things. And it's consisting of a lot of different things. We've talked about keratinocytes, we've talked about Langerhans cells, we've talked about the sebum, the oil, we talked about sweat, and when you combine all of those things and the ingredients in your sweat and oil, basically we have this nice barrier on your skin that is very toxic to bacteria and fungus. So and also the dead epithelial cells just making that barrier, right? So things can't, the live bacteria actually can't get in. So let me get my mouse working. There we go. So we have a barrier, we have chemical components, we have the lubrication from the oil, the sweat hydrates you, well, the water cools you off, right? And then we also have chemical components. I mentioned vitamin C, I mentioned the antifungal and antibacterial properties. So even though, yes, you are swarmed with bacteria on your skin right now, I don't care if you showered 5 minutes ago, you have bacteria all over you. They aren't really able to multiply. They're not really able to thrive on your skin because of all of these things put together. All of the sweat and the oil and the keratinocytes and the Langerhans cells and everything. It creates this kind of film that basically protects us from the outside world. Now, once your skin is breached and you have an opening, all that kind of goes out the window to an extent. We still have Langerhans cells, macrophages, and immune responses to fix that, but you are at more risk of an infection. We've talked about sensations. I encourage you to review that slide where we talked about the different nerve fibers that detect different things. We talked about the free nerve endings detecting hot, cold, and pain. The Pacinian or Pacinian corpuscles detecting the deep touch of the pressure, and then the Meissner's corpuscles detecting light touch. The skin also has flexibility. We talked about those desmosomes in the stratum spinosum that allow basically that rubber band-like function for our skin to stretch a little bit. And we see a really cool trade-off here. So if our number one focus, if our number one goal is protection, why wouldn't we just make 1,000,000,000 billion keratinocytes, right? Why don't we just make a shield around our body? Well, one, it would probably be hard to get that stuff out, such as sweat and oil, right? But two, we would lose flexibility. If we just have these really picture fingernails, if we just had fingernails all over your body, you would lose mobility. You wouldn't be as agile, as fast, as strong. So we kind of have this flexibility in our skin where, yes, it's protecting us, but we can still move and grow and lose weight and that kind of stuff. And then we talked about excretion as well. Your skin can get rid of waste products. It can. Uric acid, ammonia, urea, all things that are just byproducts of breaking down either proteins or nucleic acids. I mentioned alcohol, I mentioned drugs, just all sorts of things our body can get rid of through the sweat glands. Now, this isn't the major role of the skin, as we know, and the liver and kidneys are really designed to get rid of those waste products, but your skin can help. And another review slide with immunity. We talked about those Langerhans cells, also known as those epidermal dendritic cells, and basically they're just macrophages, and they just chow down on anything that is foreign. Another fascinating aspect to the skin is its role in helping with the production of vitamin D. So first things first, your skin does not make vitamin D, but it does help get the ball rolling and eventually will help the body make vitamin D. So it forms an immature or a precursor to it, thanks to skin cells being activated by UV light. So go out in the sun, get your vitamin D. Then there's a chemical cascade, or there's a string of reactions that eventually send signals throughout the bloodstream to the liver, and then from there the liver sends that almost ready vitamin D to the kidneys, and the kidneys just add this hydroxyl group, this oxygen and hydrogen to it, and then it is official activated vitamin D. So that it goes skin, liver, and then kidneys. Now vitamin D is really, really important for calcium absorption. Now, I haven't really stressed calcium too much yet, but next chapter, chapter 6 with the skeletal tissue, calcium, 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 going to be extremely important. Probably the most important thing I'm going to talk about next chapter is why we need calcium. So vitamin D helps with the absorption of calcium. So if calcium is important, vitamin D also very, very important. It can be classified as a vitamin and a hormone. Remember, a hormone is just a chemical that's floating in the bloodstream. Now, it's not exactly secreted by an endocrine gland, but it is a chemical that is floating around, gets to the liver, and then that immature form goes to the kidney. So, yes, vitamin D can be considered a hormone. Now, important note for folks with darker skin, if you have a lot of melanin, therefore you have a lot of UV protection from the UV light. So, it might be harder for you to get vitamin D production. So darker skin folks need to stay out in the sun a little longer for that same effect of vitamin D. If you live in a northern climate or you just don't like the sun that much, you can also always just go talk to your doctor and see if you can get on a vitamin D supplement. Just be careful with vitamin D supplements because if you take too much, once again, they help with calcium absorption. So good, a lot of vitamin D, awesome, great, but if you have a lot of or too much calcium, then you could start developing some weird issues such as calcium stones in your body, kidney stones, gallstones being one of them, mainly kidney stones. Not to scare you, just make sure you talk to your physician. Our next topic is homeostasis of body temperature. So the skin helps maintain our constant 98.6, give or take a degree or so, right? And we do that by basically balancing how much heat we're making in our body versus how much heat we're losing in our body. So we are constantly making heat inside of our body. When we break down food and make it into energy, the byproduct is you release heat. So what we do is we take oxygen and our nutrient, mainly sugar, and what that's going to do is it's going to give off some byproducts. It's going to give off some carbon dioxide. It's going to give off some water. It's also going to give off some energy. That's the main goal, right? Why we eat food, to get energy. But it's also going to give off heat in this process. Activity is also going to generate heat, right? Do some jumping jacks, do some push-ups for 10 seconds, and you will get a little warmer. You might want to take a jacket off, or you'll start sweating or something like that. So as we increase activity, we increase catabolism. And that's why after a workout, you may be very, very hungry because you broke down everything you need, and you need more fuel to regenerate all those muscle tissues that you broke down and all the glycogen and glucose stores that you just tapped into. So the cells that are most active in producing the most heat or giving off the most heat is the liver, because your liver is constantly at work making sure, basically filtering all of our food products and are just making sure there's no toxins in our body. And then of course your hundreds and hundreds of skeletal muscles that actually help you exercise. And then we have heat loss, and you can see that we lose a lot of heat just from evaporation and radiation. So evaporation you can see as such as sweating, and of course during hot temperature days, or just even if you're in a house or an apartment or something and it's hot, you will sweat. Also, humid conditions cause you to sweat. Now, even if you're not actively sweating, even if you're not exercising or you're not in a hot environment, if you're just sitting around watching TV all day, you still sweat. And you actually still sweat a lot, believe it or not. As long as the room temperature is below 90 degrees, you sweat about half a liter of sweat all throughout the day. Now it's not noticeable. You don't notice it. Your body, I mean that's a bottle of water, right? But it's spread out throughout your entire body, forehead to feet, and over a 24-hour course of time. But what we call this is insensible perspiration or insensible sweating. You don't detect it, you don't feel it. But your body is constantly losing heat. It is losing water in that fashion. Another reason why you need to drink a lot of water throughout the day. So you can see that radiation is the transfer of heat from a surface to another with no contact. So we can do that by dilating the blood vessels in the dermis. Now, even though the epidermis is not exactly alive, and it doesn't have a good blood flow, that's why, I mean, other than the keratinization, that's why they're dead. The dilating of the blood vessels in the dermis make that area warmer, and that's what helps warm the surrounding tissues as well. So let's go to the next slide. I'll just show you some illustrations. So illustrations here on the left, you have a pot of coffee or something. The water gets hot, eventually turns into a gas via evaporation. The bottom left, you have the sun giving off its rays to the earth. Even though the sun doesn't touch the earth, we know we have radiation, and we know that the earth warms up with the sun. And then you got a picture of a bunch of bulldogs, English bulldogs, maybe? I don't know what kind of bulldog. But anyway, and they're all just kind of stuck together, sleeping together. And the reason why they do that is to keep the heat in, right? So they don't lose heat. It's basically a blanket effect. So how can we manipulate this? How can the nervous system control this 98.6 homeostasis? If we get too hot, what do we do? If we get too cold, what do we do? Well, if it gets too hot, we do have sensors in our skin, right? And they send a message to the brain, specifically a part of the brain called the hypothalamus, and it tells the body to start sweating. So it tells those eccrine and those apocrine glands to release sweat, cool us off a little bit. But also what it's doing is this. It's causing the blood vessels at the surface, right where that dermis, epidermis area is, it's causing them to dilate. And what dilation means is get bigger. So if this is a normal size blood vessel, this tube, what vasodilation looks like is that. So vaso means vessel, V-A-S-O. It means blood vessel, and then dilation would be to get bigger. So what does that mean? What are we doing here? If our normal body temperature is 98.6 degrees, your blood is a little warmer than that. Your blood is around 100.6 degrees. It's about 2 degrees warmer than the rest of your body. So by opening up these blood vessels, by opening up these tubes, what we're doing is we're sending more heat toward the surface of the skin. As we send more heat to the surface of the skin, this evaporation effect takes place, and the sweat glands release more sweat. Once again, the purpose of sweating is essentially we're putting water on the skin. If you cool off the outside of your body, you're effectively, hopefully, going to cool off the inside of your body. And in decreased body temperatures, we're just going to have the opposite effect. So we're going to have receptors that talk to the hypothalamus, talk to the brain. And what they're going to do is definitely not sweat, right? We're going to do the opposite of sweating. And instead of the blood vessels getting larger or vasodilating, we're going to constrict them. We're going to squeeze on them. And what that's going to do is shunt blood away from the skin, so we're not warming up the skin. And that'll cause those erector pili muscles to contract and cause the hairs to stand up potentially, with a little goosebump action. Also, skeletal muscles all throughout your body can start contracting. If it's bad enough, you can start shivering to the point where your teeth start hitting together, right? It just depends how cold you are. But what we're doing is by getting that warmer blood, that 100.6 degree blood away from the skin, we're keeping that warmer temperature where it needs to be in those vital organs. So we're going to take that warm temperature and put it towards the heart, put it towards the lungs and the liver and the kidneys. Because if we're freezing to death, I think our skin can be the first thing to go. Would you agree with me? Yeah, frostbite's not that fun, but if my heart freezes or my kidneys freeze, I'm not going to live more than a few seconds, right? So that's what we're doing there.